Okay students, so in this video we're just going to do a quick revision of all the topics that we have covered till now so that they're all fresh in your minds and you don't have any confusion about them. Okay, let's start. So we learned that a stream of electrons moving through a conductor constitutes an electric current. That is because we got to know that charges flow from one point to the other because of a potential difference, and this movement of charges gives rise to a current. Conventionally, the direction of current is taken as opposite to the flow of electrons. That means if this is a circuit with a resistor, or this can be 2-3 resistors, this is the positive and the negative terminal. We know obviously electrons are negatively charged, so they go from the negative end to the positive end. So this is the electron flow direction, but the current flows opposite to the electron flow. Like we said that current is like us, like we should go in the positive direction. So current also goes from the positive to the negative. It starts from the positive, or it goes opposite to the flow of the negative charge. Like we should go opposite to negativity. Okay. We learned that the SI unit of current, we learned about the units and symbols. So symbol for current is I, and the SI unit is ampere, which is represented by capital A. Right? To set the electrons in motion in an electric circuit, we use a cell or a battery. We learned that a cell generates a potential difference. You can write generates and maintains. Right? Generates and maintains a potential difference across its terminals. So we learned that for any kind of current to flow, be it water current, be it air current, there has to be a difference of something. So in case of a circuit, it's a potential difference created by the battery. Okay, moving on. Fourth point says resistance is a property that resists the flow, or as we said, opposes the flow of electrons in a conductor. It controls the magnitude of the current. Because more the resistance, obviously current is going to find it more difficult to flow through it. So current depends on the resistance also. The SI unit of resistance is ohm. This unit is wrong. This is watts. Ohm is represented by this. Okay. Ohm's law, very, very, very important, shows that the potential difference V is directly proportional to I across a conductor. So if a conductor has a potential difference V across it, then it is proportional to I. That means if V increases across the conductor, then I also increases. Similarly, if V decreases, I decreases, and vice versa. Right? And we also learned that we introduced the constant of proportionality, which is R, which is independent of V and I. R doesn't depend on V and I. What does R depend on? Do you remember? It depends on the temperature, depends on the material, it depends on the length, and it depends on the area of cross section. Okay, great. So here it says the resistance of a conductor depends directly on length. We learned that R is proportional to L, and inversely on the cross section area, which is R is proportional to 1 by A. So combining these, we get R is proportional to L by A. And when we remove this sign of proportionality, we get R is rho L by A. And what is rho here? It is the resistivity. Right? Now, next thing we learned was about the combination of resistors. Then we derived it completely. If you want to know where this came from, where this formula came from, go back and look at the derivation video where we did the derivation. We completely and logically broke down, and then I just didn't give you this formula that this is the formula for series resistances. No, I completely explained it to you. I logically explained it to you where this formula comes from. So once you've understood that, you just remember this formula, that the series is simply addition of all the individual resistances. Okay. And in case of the parallel one, it is always 1 upon Rp. This Rp is the equivalent resistance for parallel resistors, that is resistors connected in parallel. 1 upon R1 plus 1 upon R2 plus 1 upon R3. Similarly, as many resistors there are. If there are only 2 resistors, here it is going to end by 1 upon R2. So again, in the parallel resistors video, I have completely explained it to you how this formula is derived. So once you've understood that, just remember the formula, because you won't have time like that to derive the formula every single time. But if someone asks you what's the logic behind it, or you yourself get confused about the formula, then you can quickly derive it also. Then we learned that the electric energy dissipated in a resistor is given by W is equal to VIT, or we said E is equal to VIT. Then we said that this energy is given in the form of heat. So we said H is equal to VIT also. Okay. And then you remember we also did the Joule's law of heating, which was H is equal to I square into RT. How we derived this is also in your previous videos. Next it says the unit of power is watt. Yes, this time it's correct. 1 watt of power is consumed when 1 ampere of current flows at a potential difference of 1 volt. Where this has come from? P equal to VI. So we put I as 1 and V as 1. So 1 watt is the power consumed by a resistor through which 1 ampere of current is flowing, and it has a potential difference of 1 volt across it. We take both as 1. Then we said that the commercial unit, you remember in few questions I said I'm not converting it to hours because I want it to be in the commercial unit, which is watt hour or kilowatt hour, right? So it says it is kilowatt hour, and we have simply put the derivation also. We have the derivation for this also we have done, how this, where this came from. We put 1 watt in place of 1 watt, 1 kilowatt we put 1000 watt, in place of 1 hour we put 3600 seconds. So that is how we got this value. Okay, great. Let's move on. Okay, so that brings us to the end of this chapter, current electricity. So I hope all of the concepts that we have done are clear to you now. You must remember that, especially the points that we took up in the quick revision, that are the main points of it. But don't think if some point was missed in the quick revision that it's not important. No, every single thing we did is important, because you never know in which formula or in which application you would need which numerical or which derivation. So make sure you go through all the topics, you are thorough with it, and if you have any doubts, you solve more numericals based on it from your NCERT or from any other help book or from the internet. Okay, make sure you know all the topics well, and I hope you enjoyed doing this chapter, students. Thank you so much and take care.